Now let's learn about reactions of alkaline earth metals. Number one is reaction with air. Let's see how they react with air. Beryllium and magnesium are protected by oxide film. These two elements form an oxide film on their surface, and this will protect the inner atoms from further attack. However, if you take powdered beryllium, when heated in air, powdered beryllium when heated in air, it combines with both the components of air, oxygen as well as nitrogen, and it will give a mixture of beryllium oxide and beryllium nitride. It combines with both the components of air and gives rise to a mixture of beryllium oxide and beryllium nitride. Magnesium also reacts with both oxygen and nitrogen, and you need to burn magnesium ribbon. You get a mixture of magnesium oxide and magnesium nitride. Others will react even under ordinary conditions to give MO as well as M3N2. In case of beryllium and magnesium, we need to burn it, whereas others, they react under ordinary conditions and you get a mixture of oxide and nitride. The composition is, you have more oxide than nitride because oxygen is more reactive than nitrogen. What makes nitrogen less reactive is its low electronegativity when compared to oxygen. Apart from that, there is a strong triple bond holding the two nitrogen atoms. So this is how they react with air. Let's move on to the next reaction. The next reaction we are going to discuss is reaction with water. Beryllium does not react with water. Magnesium reacts with boiling water, and you get magnesium oxide and hydrogen gas. Others react even under ordinary condition and get MOH taken twice and hydrogen gas. This M can be calcium, strontium or barium. These elements react even under ordinary conditions. Even in cold water, they react to give the corresponding hydroxide and hydrogen. Here magnesium hydroxide is not formed because the reaction takes place at a relatively high temperature. Magnesium hydroxide is not that very stable thermally, so you end up with magnesium oxide. So that's how they react with water. Beryllium is the only element which does not react with water. Magnesium reacts with boiling water, whereas the other metals react even in cold condition. The next reaction we are going to discuss is reaction with hydrogen. Beryllium does not react, does not combine directly with hydrogen. You cannot make beryllium combine directly with hydrogen. Other metals combine with hydrogen on heating and you end up with MH2. MH2 is hydride, metallic hydride. Here M can be magnesium, calcium, strontium or barium. Beryllium hydride can be obtained from this substance, beryllium chloride, reacted with lithium aluminium hydride, LiAlH4. This reaction can give rise to beryllium hydride, BH2. Remember that beryllium hydride and magnesium hydride are covalent. They are covalent hydrides. Beryllium hydride and magnesium hydride are covalent hydrides. Others are ionic hydrides. Others are ionic hydrides. That means calcium hydride, strontium hydride, and barium hydride are ionic in nature, whereas beryllium hydride and magnesium hydride are covalent hydrides. Also remember, BH2 and MgH2 are polymeric and they contain special type of bond called 3-center 2-electron bonds. These bonds are also described as banana bonds. They contain 3-center 2-electron bonds, which are also described as banana bonds. This is about reaction with hydrogen. Beryllium does not combine directly with hydrogen. You need to react beryllium chloride with some hydride transfer reducing agent, say lithium aluminum hydride will react with beryllium chloride to give beryllium hydride. Magnesium, calcium, strontium and barium, they react directly with hydrogen on heating and they give rise to corresponding hydrides. Another important thing you are supposed to know about hydrides is beryllium hydride and magnesium hydride are covalent, other hydrides are ionic. Also remember that calcium hydride is popularly called as hydrolith, and when this is reacted with water, it produces hydrogen gas. Look at the equation. I am now going to write that equation. Look at the way this substance reacts with water. Calcium hydride reacts with water to give calcium hydroxide and hydrogen gas is produced. I would like to emphasize on this. See, this is popularly called as hydrolith. In this substance, oxidation state of hydrogen is -1, whereas in this substance, oxidation state of hydrogen is +1. So this -1 hydrogen combines with +1 hydrogen and you get H2, where oxidation state of hydrogen is 0. So this is a case of hydrogen undergoes comproportionation. Same element in two different oxidation states, when it combines to give a compound in which the element has one particular oxidation state, then the process is said to be comproportionation. And the solution becomes, see, hydrogen gas escapes out and the resulting solution which is obtained will be alkaline. So if you put a piece of calcium hydride in water, the gas which is given out is a colorless gas, it is hydrogen gas, and the solution becomes alkaline. That's about reaction with hydrogen. Now the next reaction is with ammonia. The next reaction we are going to discuss is reaction with liquid ammonia. Just like alkali metals, you know, alkali metals, when dissolved in liquid ammonia, you get a deep blue colored solution. Here also, alkaline earth metal, if you take liquid ammonia, dissolve alkaline earth metal, here also you get deep blue colored solution. It's the same thing. Here also the solution will be paramagnetic, the solution will act as a good reducing agent, and it will be an electrical conductor. All those details we have discussed under alkali metals hold good for this also. Here also the metal transforms into solvated electrons and solvated cations. The metal dissolves as metal ions which get solvated, surrounded by solvent molecules. Electrons also get solvated. So the solvation energy will compensate for ionization energies I1 and I2. Same thing, deep blue solution, paramagnetic, good electrical conductor, and will act as a good reducing agent. These are the important features of this solution. So that's about reaction with liquid ammonia. So with this we complete chemical properties of alkaline earth metals. Then we'll be talking about compounds of alkaline earth metals.